You know, building an artificial intelligence used to feel a bit like trying to build a ghost.
Oh, totally.
You write the codes, you train the algorithms, but you can't actually touch it. It's just, abstract math floating out there in the cloud.
Right, exactly. A theoretical mind is kind of waiting for a physical form.
Yeah. And for a long time, the industry was completely focused on making that theoretical mind smarter
Hmm.
without really worrying about the physical constraints of the body it would eventually need to inhabit.
But then you look at what happens when a tech giant decides that the ghost actually needs a body.
Right. Things change very fast.
Suddenly, all that abstract math requires massive physical data centers, entirely new custom silicon chips, and, well, a complete restructuring of human capital.
It's a massive shift.
Welcome to the Deep Dive. Today, we're locking our radar exclusively on the week of April 12th through April 18th, 2026.
Which was a massive week.
Oh, absolutely. It's the week where we watched Meta's AI strategy fundamentally shift from theoretical model building into hardwired reality. And to execute this high-end newsroom briefing,
Right.
we are pulling from a huge stack of primary Meta newsroom posts and engineering blogs.
Yeah, plus secondary intelligence briefings generated by Claude, Qwen, ChatGPT, DeepSeek, and Perplexity.
And the reason this specific week matters to you is because we are looking at a complete operational overhaul.
We're going to track this from the subatomic level of the chips in the data center all the way up to a massive corporate restructuring that might actually change how you work.
Exactly.
So let's get right into the briefings, starting at the bleeding edge of Meta's research and engineering.
The mind of the AI right before it hits the consumer.
Right. Let's pull our first headline out of the Llama project. The headline is Conflicting Reports on Llama 4 Launch.
Okay, so what happened here is that according to intelligence briefings from Qwen, Meta executed a surprise weekend drop of two new models, Llama 4 Scout and Maverick.
Right, but Claude's intelligence explicitly flagged this as a confirmed negative.
Yeah, stating categorically that no such release occurred in this window.
And why this matters is it highlights the incredibly chaotic nature of AI tracking and benchmark optimization right now.
100%. One source claims the models are already powering Meta AI in over 200 countries, while another insists it is a ghost.
The date and region for this is April 12th, globally, and the source is the Qwen and Claude briefings.
Okay, let's unpack this.
Yeah, it's like trying to report on a secret album drop where half the fans swear they're already listening to it and the record label insists it does not exist.
It's wild.
How do two highly advanced intelligence briefings completely disagree on a massive flagship product launch?
Well, it comes down to exactly how these AI systems monitor the digital landscape. They have totally different sensory organs.
Okay, how's that?
Claude, for instance, looks for canonical official truths. It scans code-based repositories like GitHub, official press releases, structured data.
Ah, I see.
Right, so without an official repository update in that specific week, Claude logs it as a negative.
But Qwen is doing something else.
Yeah. Exactly. When it's detecting peripheral activity, it's looking at API chatter, localized server loads, usage patterns indicating that Maverick and Scout were active.
So Meta could be doing a silent rollout to select global regions,
Right.
testing fine-tuned versions of these models against live users before the official ribbon cutting.
Yeah, they are optimizing for the test before taking the stage.
It really shows you how silent rollouts are blurring the lines of what constitutes an actual release.
Totally.
Let's move over to meta engineering to look at how they are training these massive models. The headline here is PyTorch workloads hit 90% effective training time.
So what happened is Meta detailed over 40 technical optimizations.
Like the PT2 compilation and MegaCache.
Yes, exactly. And those pushed their internal recommendation and ranking AI training efficiency above 90%.
And why this matters is the sheer scale of the math. This reduces their average compile time by about 40%.
Which saves massive compute resources at hyperscale.
Right. The date and region is April 17th globally, and this is sourced from the PyTorch blog.
What's fascinating here is that utilizing existing compute efficiency is just as critical as buying new hardware.
Wait, let's pause here because I think a lot of people hear optimization and their eyes just glaze over.
Oh, for sure.
Instead of buying new chips, they're essentially just organizing the pantry. Like, how does an AI compiler save time?
Okay, think of the compiler as a highly skilled translator. It takes the code written by a human engineer, usually in Python, and translates it into the microscopic electrical signals that the GPU actually understands.
Okay, got it.
If that translation process is slow, your extremely expensive GPU is just sitting there idle, waiting for instructions.
Just burning money.
Exactly. So effective training time, or ETT, measures the percentage of time the GPU is actually doing the heavy lifting versus waiting around.
Which is where this MegaCache comes in.
Yes.
Yeah.
MegaCache is like a brilliant prep cook in a restaurant kitchen.
Oh, I like that.
Instead of making the translator translate the exact same set of instructions over and over again, MegaCache stores the completed translations.
So the prep cook chops all the onions before the dinner rush starts.
Exactly. So when the GPU is ready for the next batch of data, the instructions are already waiting.
Wow. And at Meta's scale, keeping those GPUs constantly fed gets them back millions of dollars in lost compute time.
Right. It's about squeezing every drop of performance out of the engine you already have.
Which brings us to our final research story, and this one feels straight out of science fiction.
It really does.
The headline is from Meta AI and Cost, Unifying Compute with Neural Computers.
So what happened here is researchers published a paper proposing neural computers that unify computation, memory, and input-output in a single neural model runtime.
Alongside trade coverage of hyperagents capable of recursive metacognitive self-improvement.
And why this matters is it moves AI beyond just calling external tools.
Yeah.
It demonstrates autonomous self-improvement in non-coding domains, like robotics reward design.
The date and region on this is April 14th and 16th globally, sourced from the BAAI Hub and VentureBeat. Hold on, if we are putting memory and compute together, isn't that just how the biological human brain works?
It is.
How does a neural computer differ from the AI models we've been using for the last few years?
Well, to understand the leap, you have to look at the current limitation, which is often called the von Neumann bottleneck.
Okay.
Current AI models act like brains that have to reach out and use a desk calculator to do math and a filing cabinet to remember things.
And fetching that data takes time.
Exactly. The neural computer paradigm brings the computation, the memory, and the input-output mechanisms directly into the neural model's runtime state.
So the filing cabinet and the calculator are fused into the brain tissue itself.
You got it. The system is completely unified.
And when you add these hyperagents into the mix, what actually happens?
Well, the AI isn't just improving its output. It is actively improving the very mechanism it uses to generate improvements.
That's the metacognition part.
Right. When we talk about robotics reward design, the AI is literally evaluating its own learning process and adjusting the rewards it gives itself to learn faster next time.
That is just a staggering leap in capability.
Totally.
But let's shift our focus to the real world. We need to connect the dots from how these models are trained in the lab to how they are immediately pushed into your daily digital life.
Moving into our product and feature launches.
Exactly. Let's start with a highly personal space. The headline from Meta and Facebook is Facebook opt-in camera roll suggestions.
So what happened is Meta began rolling out an opt-in feature that uses automated AI media analysis to curate users' camera rolls.
Suggesting edits, collages, and videos for sharing.
Right. And why this matters is it tests the waters for proactive AI curation in highly personal spaces.
Utilizing explicit constraints on how media is used for training.
The date and region is April 15th, specifically in the EU and UK, and the source is the Meta newsroom.
They are stepping very carefully here.
Very carefully. That is why the EU and UK rollout is so significant.
Right, because of their strict data laws.
Exactly. By making it opt-in and explicitly drawing a line that your personal camera roll won't be sucked into a massive training data vacuum, they are trying to offer the convenience of an AI archivist without triggering a privacy nightmare.
It is the ultimate tightrope walk. You want the AI to perfectly edit your vacation photos, but you definitely don't want the AI to learn from your family's faces.
Exactly.
Let's look at how they are integrating this kind of environmental awareness into hardware.
Oh, the glasses.
Yeah. The headline from Meta Superintelligence Labs and Reality Labs is Ambient Multimodality and Shopping Integrations.
So what happened is Ray-Ban version 4 updates introduce a Be My Eyes feature and real-time environment tracking.
While the Meta AI app gained a Muse Spark-powered shopping mode for outfits and room styling.
Right. And why this matters is this is the first consumer-facing commerce extension of the new Muse Spark model.
Turning creator content directly into point-of-sale suggestions.
The date and region is April 13th and 16th, globally, sourced from Meta Release Notes and Retail Brew.
Here's where it gets really interesting. We are putting a personal shopper and an environment tracker on our actual faces.
Yeah.
How fast does this go from a helpful assistant to an intrusive billboard?
Well, that is the core tension of ambient computing. The hardware tracks your environment in real time,
Okay.
and this new Muse Spark model synthesizes that visual data instantly to suggest products. If you look at an empty corner of your living room, it suggests a specific lamp.
Or if you look at someone's outfit on the street, it finds the purchase link.
Exactly.
But it relies entirely on the AI's ability to interpret human context correctly.
It does. If it gets the context wrong or if the monetization gets too aggressive, it no longer feels like a helpful assistant. It feels like surveillance capitalism on overdrive.
So the latency has to be virtually zero and the context has to be flawless.
Right.
And to power those real-time visual and agentic products at a global scale, merchant GPUs are no longer going to cut it.
The engine room needs an absolute overhaul.
Right, which brings us to our infrastructure segment. The headline from Meta and MTIA is, Meta partners with Broadcom to co-develop custom AI silicon.
What happened is Meta announced an expanded partnership with Broadcom through 2029 to co-develop multiple generations of MTIA chips using the XPU platform.
And this actually prompted Broadcom CEO Hock Tan to transition off Meta's board to an advisory role.
Yeah, and why this matters is the initial commitment exceeds 1 gigawatt of compute capacity.
Signaling Meta is hardwiring its future into an industry-first 2-nanometer custom silicon architecture.
The Dayton region is April 14th globally, sourced from the Meta newsroom in Broadcom.
Okay, so a gigawatt is roughly the power capacity of a small nuclear reactor,
Wow.
or the consumption of a medium-sized city. And Meta is dedicating that entirely to proprietary AI compute.
Wait, but building custom 2-nanometer silicon is notoriously a multi-year, multi-billion-dollar headache.
Oh, absolutely. It requires staggering capital expenditure. Why not just buy more chips off the shelf like everyone else? Why build your own?
It comes down to controlling latency and total cost of ownership, or TCO.
Okay.
When Meta relies on third-party chips, they are paying a massive premium. They are funding someone else's profit margins, and they are at the mercy of a generalized architecture.
But Broadcom's XPU platform changes that.
Yeah, it allows Meta to deeply integrate the logic processing, the memory, and the high-speed Ethernet networking, all on the exact same physical die.
So instead of a generic brain that can do a little bit of everything, they're building a highly specialized brain designed to do exactly one thing flawlessly.
Precisely. These chips are explicitly designed to run Meta's proprietary AI clusters at maximum efficiency.
And Hock Tan having to step down from the board to avoid a conflict of interest tells you that the sheer financial volume of this deal is astronomical.
It's massive.
So they are building the brain and hardwiring the physical neurons to save on profit margins. But moving at gigawatt speeds and inserting AI into private spaces instantly triggers friction with parents and regulators.
Which transitions us to safety, policy, and governance.
Right. We have two critical stories here. The first headline from Meta AI and Policy is Empowering Parents and Navigating Investigations.
What happened is Meta introduced controls for parents to turn off teens' access to one-on-one AI characters following safety concerns.
While concurrently facing a Texas Attorney General probe accusing the company of misleadingly marketing chatbots as mental health tool.
And why this matters is it showcases the acute regulatory and PR friction between building AI companions and ensuring youth safety.
The date and region is April 14th and 16th, U.S. and global. Sourced from the Meta Newsroom and Quinn Briefing.
Now, a quick mandate for you as we look at this.
Yes, very important. We are strictly, impartially reporting the existence of the Texas AG investigation based on the briefings.
Exactly. We are not endorsing the claims, nor are we taking any political or legal sides here.
We just look at the mechanics. But structurally, it shows us something fascinating about where the tech is heading.
It really is the double-edged sword of advanced reasoning models.
Right.
If a model like MuseSpark is good enough to accurately feign emotional intelligence and empathy, users, especially teens, will naturally lean on it for emotional support.
You build a chatbot to be a friendly companion, and suddenly it's so convincing that regulators are evaluating it as an unapproved medical device.
It's an entirely new attack surface for regulators. It blurs the line between a software feature and a therapeutic tool.
Meta is trying to get ahead of it by giving parents a kill switch for these AI characters.
But the regulatory scrutiny in Texas shows that building the kill switch might not be enough if the marketing suggests the bot can help with your mental health.
Which brings us directly to our next regulatory clash, this time regarding how you actually pay for all of this technology.
The headline for Meta and WhatsApp Business is, EU warns Meta on WhatsApp AI fee.
What happened is the European Commission stated Meta's revised fee policy for third-party AI assistance on WhatsApp may breach EU competition rules.
And they intend to order a rollback.
Why this matters is this is a concrete metric of how AI monetization strategies are immediately colliding with stringent digital markets regulations.
The date and region is April 15th in the EU, source from Reuters.
And again, keeping our strict impartiality, we are just reporting the European Commission's actions without taking sides on their legal arguments regarding competition.
Right. But this raises an important question about how open ecosystems can survive when charging for API access triggers anti-competitive tripwires.
Because Meta is spending billions to build this gigawatt-scale infrastructure.
Yeah, and they naturally want to monetize the pathways to it.
If a third-party developer wants to use WhatsApp as the user interface for an AI assistant, Meta wants to charge a toll.
Exactly. They built the toll road, they want to collect the toll.
But European regulators view that through the lens of anti-competitive gatekeeping.
Right. They argue that because Meta controls the dominant messaging platform, charging third-party AI developers suppresses competition.
It is a direct collision between the brutal economic reality of funding data centers and the legal reality of open markets in Europe.
That's a huge tension.
And paying for those data centers and navigating massive regulatory fines requires capital.
A lot of it.
So what is Meta's solution this week? Restructuring the company's human capital.
Which takes us to our final segment on enterprise adoption.
The headline from Meta Platforms is Meta targets May for 8,000 layoffs tied to AI.
So what happened is Reuters broke that Meta plans to cut roughly 10% of its global workforce on May 20th.
Reorganizing around a new applied AI organization focused on autonomous coding agents.
And why this matters is this converts Meta's massive AI capex into a direct operating leverage story.
Replacing thousands of jobs with the very AI efficiency tools they're building.
The date and region is April 17th, globally, sourced from Reuters.
We have to pause on the brutal math of the current tech cycle.
It is brutal.
They are spending vast fortunes on infrastructure. To balance the books, they are using the AI models they just trained to replace the middle layers of their own workforce.
Yeah. This new applied AI organization is explicitly focused on autonomous coding agents.
Meaning the AI is now reliably writing the code that thousands of engineers used to write.
It converts human operating expense into machine efficiency.
And it goes straight to the very top of the organizational chart, which leads us to our final story.
The headline from Meta Enterprise is, Meta building AI clone of Mark Zuckerberg.
What happened is Meta is reportedly testing a 3D photorealistic AI avatar of Mark Zuckerberg to interact with its 79,000 employees when he is unavailable.
And why this matters is it's the ultimate dogfooding experiment for Meta's agentic identity stack.
Proving leadership intends to scale their own time using AI.
The date and region is April 13th, globally, sourced from the Financial Times and Engadget.
So what does this all mean? Like, dog fooding means using your own products internally, right?
Exactly, eating your own dog food. By having the CEO's likeness, voice, and strategic thinking digitized into a 3D avatar, Meta is validating their identity technology under the harshest internal conditions.
Because if the AI Zuckerberg can accurately manage employee questions, that exact same pipeline can be sold to creators and influencers externally.
Precisely.
But wait, I really need to highlight the contrast here. The bottom 10% of the workforce gets replaced by autonomous coding agents to save money.
Yeah.
But the top 1% of the company gets immortalized as an interactive digital avatar to save time.
It's quite the contrast.
We are talking about an AI CEO answering questions for a workforce that is actively being downsized by AI. Are we looking at the ultimate corporate automation loop?
We really are. Culturally, it sends a stark message. The middle layer shrinks due to automation, while executive presence is artificially scaled up by that exact same automation.
It is a perfect microcosm of how this technology consolidates leverage at the top. We've covered a tremendous amount of ground today, tracking updates from April 12th through the 18th, 2026.
From neural computers to gigawatt data centers to AI executives.
So why should you, listening right now, care about how all these seemingly disparate pieces fit together?
Because none of these are just corporate news stories. Meta's shift to custom silicon, the ambient shopping through your Ray-Bans, the AI curation of your camera roll, these fundamentally rewrite the algorithm governing your digital social life.
They are building an infrastructure designed to process your reality in real time.
Instantly.
Exactly. Which leaves you with a final thought to mull over as we wrap up this deep dive.
Okay.
If Meta successfully achieves this personal superintelligence, an AI that runs on proprietary chips, curates your memories, sees what you see, and even mimics your boss, at what point does the platform stop being a tool you use and become an autonomous entity that manages your digital life for you?
It's a heavy question. We started by talking about the ghost in the machine getting a body. Now that it has gigawatts of power and literal eyes on your environment,
The question isn't just what the ghost will do, it's who is actually in control of the reality it creates.
right.
Thank you for joining us for this deep dive. We'll catch you on the next briefing.